Hello and welcome to tonight's sleepy science story. If you're listening in bed, let the day loosen its grip for a moment. Here, you don't need to think, solve, or hurry. Just breathe. In a few seconds, we'll drift into a quiet corner of the universe where distant worlds glow softly and time itself seems to slow. Think of this as your nightly escape, a gentle place where curiosity feels like comfort and science becomes a lullaby. So settle in, relax your shoulders, and let your mind follow the calm. Tonight, sleep begins with a story. Let your breathing settle, your thoughts drift outward, and your body grow lighter, as if the pull of gravity has gently eased its hold, and you're beginning to float through the quiet of the cosmos. Tonight, we'll take a slow, dreamlike wander across the solar system, not racing from world to world, but gliding in calm spirals past warm suns, faint rings of dust, hidden oceans beneath frozen crusts, and ancient shadows carved into alien terrain. This journey isn't about figures or formulas. It's a story written in magnetic tempests, drifting moons that glow faintly in the dark, and planets tilted so strangely they seem to roll around the sun. From sideways spinning worlds to storms that forge diamonds, to sunlight millions of years old still crossing the void, every orbit carries its own quiet wonder. We'll travel gently, unhurried, meeting one soft fact at a time. And before we drift any deeper, if these peaceful explorations help calm your mind or ease you towards sleep, you're welcome to tap the like button and subscribe. It helps others find their way here when they need a quiet escape. Now, let's begin. Despite being the most distant major planet from our sun, Neptune hosts winds unlike anything found on Earth. In its upper atmosphere, gales roar at more than 2,000 kilometers per hour, faster than the speed of sound back home. Imagine winds 5 times stronger than those pushing a commercial jet. These furious currents seem to draw power not from sunlight, but from Neptune's own internal heat, which still rises through its icy layers. With an atmosphere rich in hydrogen, helium, and methane, these winds sculpt enormous storms and swirling patterns across the planet's soft blue haze. It may be a frozen world, but it's one in constant, supersonic motion. Spreading across more than 4,000 kilometers, Valles Marineris stretches along Mars's equator, like a wound carved across the planet. It's so vast it would stretch from one side of the United States to the other. In its deepest places, it plunges more than 7 kilometers, over 5 times the depth of the Grand Canyon. Unlike the river-carved gorges of Earth, this colossal scar was shaped by Mars tearing itself open. Scientists think it formed through the planet's crust being pulled apart, pushed upward by volcanic forces, and eroded over time. It stands as a frozen reminder of Mars's once violent geological heart. Although Venus closely resembles Earth in size and composition, it lacks a feature essential to life on our planet: a global magnetic field. Earth's magnetic shield forms as molten iron churns in its outer core, creating a protective bubble that deflects solar particles. Venus, however, appears to have a sluggish or possibly solid core, unable to generate the same dynamo. Without this shield, the planet's upper atmosphere is constantly battered by solar wind. stripping away lighter gases. This absence of protection may be one reason Venus, which might once have been Earth-like, transformed into the scorching, hostile world we see today. Diamonds may fall as rain on Uranus and Neptune. Deep within the icy giants, the extreme pressure and heat may create thunderstorms unlike anything imaginable. Their thick, methane-rich atmospheres can cause carbon atoms to break free and compress into tiny crystals, forming diamonds. These sparkling fragments may drift downward in shimmering storms, sinking slowly through the dark interior layers. Laboratory experiments on Earth have recreated this process, showing how hydrocarbons can transform into diamond under intense conditions. If the theory holds true, then far out in the deep blue reaches of our system, diamond rain may be drifting through alien skies. Earth stands alone with moving tectonic plates. One of the rarest and most life-supporting features in the solar system lies right beneath your feet. Earth's crust is broken into great floating plates, drifting slowly over a sea of molten rock. These shifting plates build mountain ranges, trigger earthquakes, renew minerals, and help stabilize the planet's climate by cycling carbon over millions of years. Although scientists continue searching, no other world yet shows clear signs of this intricate, living geology. It's one of the many reasons Earth remains uniquely capable of supporting complex life. Let your breathing settle, your shoulders release, and your mind drift as though gravity has eased its hold, and you're beginning to float quietly through the dark. Tonight, we'll wander through the solar system in slow, gentle spirals, gliding past warm planets, icy rings, shadowed craters, and oceans frozen beneath ancient shells. You won't need numbers or equations, only curiosity. Let magnetic storms, tilted worlds, glowing moons, and forgotten sunlight guide you. Every orbit hides something strange and softly beautiful. And if these sleepy journeys bring you comfort, a tap on the like button helps others find their calm little corner of the cosmos. Now, let's begin. Far beyond the warmth of the sun, Neptune spins with storms fiercer than anything on Earth. Its winds roar across the upper atmosphere at more than 2,000 kilometers per hour, faster than sound travels here at home. Despite the cold, Neptune radiates its own internal heat, feeding these enormous tempests. Made of hydrogen, helium, and methane, its pale blue clouds are carved into sprawling, shifting storm systems. A frozen world wrapped in winds that never seem to slow. Mars holds a canyon the size of a continent, stretching over 4,000 kilometers across the Martian equator lies Valles Marineris, a canyon that would cut from coast to coast across the United States. In some places, it sinks 7 kilometers deep, dwarfing the Grand Canyon many times over. Unlike the river-carved valleys on Earth, Mars' Great Scar was shaped by a mixture of volcanic heat, tectonic stretching, and the slow collapse of a cooling planet. It's a frozen reminder of the violence that once reshaped Mars' surface. Though Venus mirrors Earth in size and composition, it lacks a magnetic field, a shield our planet forms through the churning motion of molten iron in its core. Venus's core seems sluggish or even solid, unable to spark the same protective dynamo. Without that shield, the solar wind strips away lighter gases, leaving behind a thick, choking atmosphere. It's one of the reasons Venus transformed from a world that might once have resembled Earth into a furnace of heat and pressure. Deep within the icy giants, far below the clouds, pressures climb so high that methane molecules break apart. Freed carbon atoms compress into crystals, tiny diamonds drifting downward through the dark interiors. Experiments on Earth have recreated this transformation, suggesting these distant planets may host glittering storms where diamond rain falls silently toward the hidden cores. Our planet is unique in having active plate tectonics, a restless shell of shifting plates that glide over the mantle below. These plates raise mountains, trigger earthquakes, recycle carbon, and help stabilize Earth's climate over millions of years. Mars and Venus have fractures and volcanic plains, but they're quiet now, geologically frozen. Earth's living surface may be one of the secrets behind its long-lasting habitability. Not all asteroids wander alone. Some travel with small companions, tiny moons caught in their gravity. The first discovered, Dactyl, was found orbiting the asteroid Ida in 1993. Since then, scientists have found dozens more, including pairs of asteroids that orbit each other like slow dancers in the dark. Even the smallest bodies in space can form partnerships shaped by gravity's gentle pull. Mercury doesn't have a true atmosphere. Instead, it's wrapped in an exosphere, a delicate veil of atoms knocked from its surface by solar wind and micrometeoroids. These particles drift freely, almost never colliding, and constantly escape into space. New ones replace them, creating a faint, shimmering shell of sodium, potassium, and oxygen, trace elements floating over a planet scorched by the sun. Every second, the sun turns millions of tons of its mass into light and heat through nuclear fusion. That energy spills outward across the solar system, warming Earth and shaping every world it touches. The mass it loses is tiny compared to its size, but over billions of years, it's enough to slowly change the star we depend on. For now, it burns steadily, giving away a little of itself with every heartbeat. The rings of Saturn, so bright and delicate, are slowly slipping away. Gravity and magnetic forces pull their icy particles into the planet, a process known as ring rain. Cassini's measurements suggest the rings are surprisingly young and may disappear entirely in a few 100 million years. For now, they shine as one of the solar system's most beautiful but temporary spectacles. Mars is a cold desert, but its atmosphere can erupt into enormous dust storms that engulf the entire planet. These storms can last for months, blocking sunlight and reshaping the surface with fine, rust-colored dust. Some start as small gusts and grow through feedback loops of heat and wind. One such storm ended the Opportunity rover's long mission, burying its solar panels under a blanket of dust. Beneath Europa's bright, cracked shell of ice lies a vast global ocean. Tidal forces from Jupiter stretch and squeeze the moon's interior, generating heat that likely keeps this ocean liquid. The surface, etched with dark lines and ridges, hints at shifting ice plates. Magnetic readings and chemical signatures all point to a deep, salty sea, a dark, secret ocean that may hold ingredients for life. Olympus Mons rises nearly 22 kilometers above Mars, almost triple the height of Everest. It spreads so wide that it could cover an entire US state. Without plate tectonics to move the crust, volcanic eruptions kept piling lava in the same place for millions of years. The result is a colossal shield volcano standing alone on the silent Martian plains. Although Saturn's rings stretch hundreds of thousands of kilometers across, they're astonishingly thin, often less than 100 meters thick, made mostly of ice. From tiny grains to massive chunks, they form a nearly perfect flat disk shaped by gravity and shepherd moons. From a distance, they look solid, but up close, they're delicate, translucent, and filled with empty space. Among all the planets, Earth is the densest, packing more mass into each cubic centimeter thanks to its iron-rich core and rocky mantle. It's another quiet reminder of how unusual our home planet really is. Earth may not be the largest world in our solar system, yet it is the densest. Each cubic centimeter carries roughly 5. Every tremor reveals flows of plasma, magnetic knots, and the heartbeat of fusion at the core. The sun is never quiet. It sings constantly. And then there is Venus, a planet that turns with a rhythm entirely its own. It rotates backward, spinning so slowly that one Venusian day lasts longer than its entire year. On this furnace world, the sun rises in the west and slips below the eastern horizon. No one is certain how this reversal occurred. Perhaps a colossal early collision toppled its axis, or maybe tidal forces twisted its rotation over time. Whatever the cause, Venus drifts through space with an almost dreamlike spin, unlike any other world. Jupiter, by contrast, is a realm of abundance, not only in size, but in company. More than 90 moons circle this gas giant, forming a miniature solar system bound within its massive gravity. Its 4 largest moons, Io, Europa, Ganymede, and Callisto, were first spotted by Galileo in 1610. But beyond them lies a cloud of irregular, captured worlds, some only kilometers across, some moving in reverse orbits. They are fragments of history caught in Jupiter's orbit, drifting in a gravitational dance millions of years old. Even Mercury, scorched by sunlight and frozen by nightfall, hides surprises. At its poles, deep within craters that sunlight never touches, sheets of ancient ice lie preserved. These shadowed basins act as natural vaults, cold enough to protect water for eons. Radar reflections from passing spacecraft have revealed these bright patches, likely delivered by comets or released from the planet's own interior long ago. In one of the harshest environments in the solar system, water endures, locked away in darkness. Far beyond the familiar planets, Pluto holds secrets beneath its icy, heart-shaped plain. Sputnik Planitia. Evidence from the New Horizons mission suggests that beneath this frozen crust may lie a hidden ocean, kept warm not by sunlight, but by slow radioactive heat and thick insulating layers above. Even at the edge of the sun's influence, liquid water may be quietly moving beneath the surface of this distant world. Closer in, the asteroid belt is nothing like the crowded obstacle course from science fiction. Though it contains millions of rocky bodies, the space between them is enormous. A spacecraft could travel through without ever seeing a large rock nearby. Most of the belt's mass is concentrated in a few large worlds, like Ceres and Vesta. The rest are scattered remnants from the early solar system, fragments that never joined to form a planet. Uranus carries its own unusual story. With its axis tipped more than 90 degrees, it doesn't spin upright like most planets. It rolls around the sun on its side. This extreme tilt creates seasons where the poles spend decades in sunlight, followed by decades of darkness. Scientists believe a violent collision long ago may have knocked the planet into this strange orientation, giving it one of the most unusual climates in the solar system. And Jupiter's mighty magnetic field holds another danger. belts of radiation so intense they would destroy an unprotected spacecraft in hours. These charged particles, caught in the giant's magnetic grip, create zones far stronger than Earth's Van Allen belts. Even Jupiter's moons must endure this extreme environment, their surfaces and atmospheres shaped by the constant bombardment. To orbit Jupiter is to wander through a realm wrapped in invisible danger. Its radiation belts are so fierce that any spacecraft venturing close must carry heavy shielding or follow carefully planned low-exposure paths. It's a beautiful giant, but one that hides storms of energy no eye can see. The Sun, meanwhile, is the anchor of our entire system, holding nearly all of its mass within a single blazing sphere. Over 99.8% of everything, planets, moons, comets, dust, circles one star. Its gravity ties the solar system together, and its immense mass powers the fusion at its heart, endlessly transforming hydrogen into light, warmth, and life itself. Far beyond Neptune lies a silent kingdom of icy bodies, home to far more dwarf planets than classical ones. Pluto may be the most familiar, but worlds like Eris, Haumea, and Makemake share its status. Countless more drift in the Kuiper Belt and beyond, untouched relics from the dawn of creation, holding ancient secrets of how our system took shape. On Venus, time moves strangely. The planet spins so slowly that one full rotation lasts 243 Earth days, longer than its entire year. Because of this sluggish backward spin, Venus endures sunless stretches and surface temperatures hot enough to melt metal. It's a world of slow-turning heat and pressure, almost timeless in its stillness. Saturn's moon Titan holds lakes, but not of water. Its rivers, seas, and rainfall are made of liquid methane and ethane, flowing beneath an orange, hazy sky. Storms drift across its surface, carving alien coastlines. And deep below the crust, scientists suspect a hidden ocean of liquid water may lie in the dark. Mars, too, keeps a pair of strange companions. Phobos and Deimos, tiny lopsided moons, look more like captured asteroids than natural satellites. One drifts slowly outward, while the other spirals gradually inward, destined one day to shatter or fall. They are the last quiet witnesses of a chaotic past. Jupiter itself glows from within. It releases more heat than it receives from the sun, radiating leftover warmth from its ancient formation. That internal fire stirs its storms, its belts, its lightning, its great red swirls, and in infrared light, the planet shines like a dim ember beneath cloud layers. With just a bit more mass, it could have become a second sun. Neptune arrived in human knowledge, not through sight, but through numbers. Subtle shifts in Uranus's orbit hinted at an unseen world, and mathematicians calculated where it must be. When telescopes finally turned to the predicted spot, Neptune appeared exactly where the equations had placed it, a planet discovered first on paper, then in the sky. At Saturn's North Pole, the atmosphere shaped something almost unreal, a colossal, perfectly edged hexagon turning slowly around the pole. Wider than Earth itself, the structure seems carved by wind and rotation, a natural geometry sculpted by fluid and motion. A long-lasting mystery swirling in icy blue light. And finally, the sun hides one of its strangest truths. Its atmosphere is far hotter than its visible surface. While the photosphere glows at roughly 5,500 degrees, the corona above it soars to temperatures of over 1,000,000 degrees. A counterintuitive, turbulent halo powered by magnetic forces we are only beginning to understand. To explore Jupiter up close, spacecraft must be equipped with special shielding or carefully navigate regions of lower radiation. While breathtaking to behold, the planet is wrapped in invisible hazards. At the heart of our solar system, the Sun dominates not only with light and gravity, but with astonishing mass. Containing more than 99.8% of the solar system's total mass, it binds every planet, moon, asteroid, and comet in orbit. This enormous weight fuels nuclear fusion at its core, transforming hydrogen into helium and radiating energy across space, sustaining life on Earth and driving the cosmic rhythm of our system. Beyond Neptune lies a scattered population of icy bodies, many large enough to qualify as dwarf planets. Pluto is the most famous, but countless others such as Eris, Haumea, and Makemake share this distant, frozen domain. Some are round, some irregular, but all are ancient remnants from the formation of the solar system, quietly orbiting in the frigid outskirts and preserving the story of our cosmic past. Venus is a world where a single day outlasts an entire year. The planet rotates slowly, completing one full spin in 243 Earth days, while circling the Sun in just 225 days. This lethargic rotation, combined with crushing atmospheric pressure and searing heat, creates a planet of long, sunless days, simmering under an acidic, greenhouse-rich sky. Saturn's largest moon, Titan, hosts lakes and rivers, but not of water. Methane and ethane carve its alien landscape, while nitrogen-rich clouds bring seasonal storms. Beneath the icy crust, a subsurface ocean of water may exist, hinting at hidden, familiar processes on a truly alien world. Titan is a place where shapes we recognize, lakes, rivers, coasts, exist in forms entirely unlike Earth. Mars is orbited by two tiny moons, Phobos and Deimos, both irregular, cratered, and likely captured asteroids. Phobos is slowly spiraling inward, destined to break apart or crash into Mars, while Deimos drifts outward. These small moons are quiet witnesses to the planet's turbulent history, remnants of cosmic chaos preserved in orbit. Jupiter emits more energy than it receives from the Sun, a glow born of leftover heat from its formation. This internal warmth drives the planet's turbulent storms and swirling bands, making it a giant not just in size, but in activity. In infrared light, it gleams like a simmering ember beneath its cloud layers, a massive planet that nearly became a star. Neptune was first discovered not by telescope, but by mathematics. Astronomers noticed anomalies in Uranus's orbit and calculated the presence of a hidden planet. When telescopes were pointed at the predicted location, Neptune appeared. It was the first planet discovered through calculation alone, a testament to the power of celestial mechanics. At Saturn's North Pole, a mysterious hexagonal storm spins with remarkable precision. Over 30,000 kilometers wide, larger than Earth itself. Lab experiments with rotating fluids show that such geometric patterns can emerge naturally. Yet seeing one in a planetary atmosphere remains a breathtaking reminder of nature's elegance. The Sun itself conceals another wonder. Its outer atmosphere, the corona, is far hotter than its visible surface, reaching over 1,000,000 degrees. This extreme heat may arise from magnetic waves or tiny solar explosions called nanoflares, sending energy outward in ways that continue to puzzle scientists. Beyond Neptune, the Kuiper Belt stretches across billions of kilometers, a frozen repository of primordial bodies, including Pluto, Eris, Haumea, and Make. Some are dwarf planets, others irregular objects tumbling silently through space. It is a cosmic archive of the materials that formed the outer solar system. Even farther lies the hypothesized Oort cloud, potentially stretching a full light-year from the Sun. Though never directly observed, this distant shell of icy bodies is believed to be the source of long-period comets, a final frontier marking the edge of the Sun's gravitational influence. Jupiter's moon Io is the most volcanically active world known, its surface constantly reshaped by eruptions of molten rock and sulfur, with plumes soaring hundreds of kilometers. Tidal forces from Jupiter and neighboring moons flex its interior, generating intense heat. Io is a world in constant motion, a molten heart encased in rock. Neptune's largest moon, Triton, orbits backward in a retrograde path, hinting it was captured from the Kuiper Belt. Its icy surface hosts cryovolcanoes and a thin atmosphere that expands and contracts with the seasons. Triton is a distant, cold world, defying expectations at every turn. Earth's moon is unusually large relative to our planet, roughly a quarter of Earth's diameter, likely formed from the aftermath of a massive collision in the early solar system. It has shaped tides, climate, and planetary stability over billions of years, a silent companion with profound influence. Our moon is more than a mere companion. It is a relic of cosmic collision and renewal, a witness to the violent early days of our planet. Planetary orbits are far from perfect circles. Most planets follow slightly stretched elliptical paths around the Sun, with a closest approach called perihelion and a farthest point known as aphelion. And 0.5 grams of tightly packed material, a concentration even greater than Jupiter's, despite the gas giant's immense bulk. This compact structure helps power the molten currents of iron in Earth's outer core, the motion that forges our magnetic shield. Layer by layer, from crust to mantle to core, our planet's internal heaviness shapes its gravity, its geology, and the invisible protection that keeps life safe from the harshness of space. The Sun, too, has a hidden rhythm. Though silent to our ears, its surface ripples with pressure waves rising and sinking within the star's blazing body. These slow, deep vibrations behave like the low notes of a cosmic instrument, echoing through the solar interior. Through heliophysics and solar oscillation studies, scientists trace these waves to read the Sun's inner workings, much like listening through stone to learn the secrets beneath the Earth. For planets like Mercury and Pluto, this difference is dramatic, affecting seasonal intensity, solar radiation, and orbital speed. Johannes Kepler first described these elliptical motions in the 1600s, forever reshaping our understanding of the solar system's elegant celestial mechanics. Some comets hail from the edge of interstellar space. Long-period comets, appearing only every few thousand years, originate in the distant Oort cloud, a halo of icy debris nearly a light-year from the Sun. These frozen wanderers are nudged into the inner solar system by passing stars or galactic tides, often lighting up with spectacular tails visible from Earth. Many have drifted silently for billions of years, untouched, only to briefly reveal the ancient material of the early solar system. The Sun itself has a finite life. In roughly 5 billion years, it will exhaust its core hydrogen and swell into a red giant, potentially engulfing the inner planets. Its outer layers will eventually be shed in a glowing shell of gas, forming a planetary nebula, leaving behind a dense, Earth-sized white dwarf, composed mostly of carbon and oxygen. Though it will no longer generate energy, this stellar ember will cool slowly over trillions of years, marking the final chapter in the Sun's long journey. Mars, though colder and thinner in atmosphere, experiences seasons much like Earth. Its 25-degree axial tilt directs sunlight differently across hemispheres during its orbit, creating spring, summer, autumn, and winter. Martian seasons are longer than Earth's due to the planet's extended orbit and influence polar ice caps, dust storms, and subtle atmospheric changes. Jupiter's moon Ganymede holds the title of the largest natural satellite in the solar system, even surpassing Mercury. With a diameter exceeding 5,000 kilometers, it features a rocky core, a potential subsurface ocean, and a scarred icy crust. Remarkably, Ganymede generates its own magnetic field, producing shimmering auroras in its thin atmosphere. Beneath the ice, layers of water may exist in complex configurations, creating a quiet, hidden world within Jupiter's magnetic embrace. Pluto occasionally comes closer to the Sun than Neptune. Its highly elliptical orbit means that during certain periods, Pluto moves inside Neptune's path. From 1979 to 1999, Pluto was temporarily the 8th planet by proximity, yet the two never collide. Their orbits are in perfect resonance. Pluto completes 2 circuits for every 3 of Neptune, maintaining a delicate celestial dance, guided by gravitational rhythm. The Sun reverses its magnetic polarity approximately every 11 years. In this solar magnetic cycle, the north and south poles switch places, influencing sunspot activity, solar flares, and coronal mass ejections. This rhythm is a reminder of the dynamic, ever-changing forces at work within our star, shaping the solar environment that touches every planet and moon. At the height of the solar cycle, known as solar maximum, the Sun bursts with increased activity. More intense radiation, stronger magnetic storms, and heightened solar wind. As the cycle wanes towards solar minimum, activity diminishes. These pulsations influence Earth's upper atmosphere, satellites, and even the auroras. The Sun's magnetism flows and shifts like a breathing heartbeat, a dynamic rhythm echoing through the solar system. Planetary alignments do not trigger natural disasters. Despite popular myths, the combined gravitational pull of distant planets on Earth is minuscule compared to the influence of the Moon or the Sun. Even during rare alignments, their effects on tides or seismic activity are negligible. Such configurations are a beautiful cosmic choreography, a silent dance of worlds, not a harbinger of catastrophe. Escaping the Sun's gravity takes decades. Spacecraft such as Voyager 1 and 2, launched in the 1970s, have only recently crossed into interstellar space, traveling over 60,000 kilometers per hour. Traversing the planet's orbits and the Kuiper Belt, these probes carry functioning instruments and a golden record of Earth, our quiet emissaries venturing into the dark. Earth's magnetic field shields life from the Sun's charged particles. Generated by the movement of molten iron in our outer core, This invisible force deflects harmful solar and cosmic radiation, preserving the atmosphere and surface. Some particles are guided toward the poles, producing shimmering auroras of green, red, and violet. Without this protective magnetosphere, our planet might resemble Mars, stripped and barren. The Moon is slowly drifting away from Earth, receding roughly 3.8 centimeters each year. Tidal interactions between the Earth and Moon push it outward, gradually lengthening our days. Billions of years from now, total solar eclipses will no longer occur, and the Moon will appear much smaller in the sky, a subtle reminder of the ever-changing cosmos. The Kuiper Belt contains icy worlds with mirrored surfaces. Beyond Neptune, dwarf planets and smaller frozen bodies like Haumea and Eris gleam brightly, reflecting sunlight like distant, cold mirrors. Haumea spins rapidly, shaped like a football, while Eris shines brighter than freshly fallen snow. Many of these worlds may have been resurfaced by impacts, cryovolcanism, or chemical processes, preserving the frozen record of the early solar system. Saturn's tiny moon Enceladus sprays water into space from its south pole. Towering geysers erupt through cracks known as tiger stripes, powered by tidal heating from Saturn's gravity. Beneath the icy crust, a subsurface ocean may harbor conditions suitable for life. Some of the ejected material replenishes Saturn's E-ring, creating a tangible connection between planet and moon. Not all asteroids are solid rock. Many are rubble piles, loosely held together by gravity, formed from the fragments of ancient collisions. These fragile bodies often contain large voids, spin irregularly, and can shift shape under pressure. Missions such as Hayabusa 2 and OSIRIS-REx have revealed their porous, chaotic nature. They are relics of early planetary construction, drifting silently through space. Mercury's core is disproportionately large, dominating much of the planet's interior. This dense metallic heart shapes its magnetic field, thermal evolution, and surface geology, creating a world both extreme and intriguing. A tiny planet with a massive secret at its center. Mercury may be small, but its iron core is disproportionately enormous, making up around 80% of the planet's radius, far larger than what we see in Earth or Venus. Scientists are still debating why. One theory suggests Mercury once had a thicker, rocky mantle that was stripped away by a colossal impact. Another proposes it formed closer to the Sun, where heavier elements naturally accumulated. The result is a thin-crusted, metal-heavy world with a relatively weak magnetic field, a survivor from the chaotic early days of the solar system. Venus is a solitary planet, with no moons at all. Unlike Earth, which boasts a large lunar companion, Venus orbits alone. The reasons remain uncertain. Some scientists speculate Venus may have lost a moon to a collision, while others argue that its slow, retrograde rotation makes stable orbits impossible. Whatever the cause, Venus drifts through space as a bright, cloud-enshrouded world, silently tracing its path without a satellite to accompany it. Most of the solar system's moons belong to the gas giants, while rocky planets like Earth and Mars have only a few. Jupiter and Saturn host dozens of moons, from tiny captured asteroids to massive worlds like Ganymede and Titan. Uranus and Neptune also hold numerous icy satellites, some hiding subsurface oceans. These sprawling systems resemble miniature solar systems, sculpted by gravity over billions of years. As we venture farther from the Sun, we find more companions orbiting quietly in the cold. Hubble has observed planets from its perch above Earth, even from low Earth orbit. The Hubble Space Telescope captures extraordinary detail. Jupiter's swirling cloud bands, Neptune's distant storms, and the seasonal changes of Mars. Long-term monitoring complements spacecraft flybys, offering insight into evolving weather, auroras, and ring systems. From its silent orbit, Hubble watches our neighboring worlds, revealing subtle shifts and cosmic rhythms that would otherwise go unnoticed. Jupiter's Great Red Spot is a tempest centuries in the making. This colossal storm, wide enough to engulf multiple Earths, has raged for at least 350 years. Its deep red hues may result from complex chemical reactions in the planet's upper atmosphere. Winds along its edges exceed 400 kilometers per hour, making it a raging multi-century vortex. Unlike Earth's short-lived storms, the Great Red Spot is a persistent symbol of Jupiter's turbulent and enduring atmosphere. Neptune radiates more heat than it receives from the Sun. Though distant and frigid, this gas giant emits roughly 2.6 times more energy than it absorbs, powering furious winds and dynamic storms. The source of this internal heat remains a mystery, potentially stemming from residual formation energy, slow gravitational contraction, or radioactive decay. Despite its cold exterior, Neptune is alive with movement, a planet of hidden warmth shaping relentless atmospheric currents. Earth is unique in hosting water in all three states: solid, liquid, and gas. Ice, oceans, lakes, clouds, and vapor coexist and cycle continuously, sustaining life. Other planets may show traces of water, but none maintain this dynamic, planet-wide presence. On Earth, water flows, freezes, and evaporates in a harmonious cycle that underpins climates, weather, and life itself, a perpetual, life-giving rhythm. The heliopause marks the edge of the Sun's influence. As solar wind streams outward, it eventually meets the interstellar medium, a thin expanse of gas and dust between stars. This boundary, known as the heliopause, represents the outer limit of the Sun's protective bubble, the heliosphere. Voyager 1 crossed this frontier in 2012, and Voyager 2 followed in 2018, entering interstellar space. Beyond this boundary, galactic forces outweigh the Sun's wind, defining the threshold between our star's domain and the vast cosmos beyond. Our solar system is drifting through the local interstellar cloud, a tenuous region of gas and dust within the Milky Way. This gentle motion carries the planets, moons, and sun together through space, surrounded by the quiet hum of the galaxy, a cosmic voyage spanning billions of kilometers, unnoticed yet continuous as the solar system sails through the stars. The local interstellar cloud is a thin, sprawling concentration of gas and dust stretching about 30 light-years across. It forms part of a larger structure known as the local bubble, created by ancient supernova explosions. As the Sun drifts through this cloud at roughly 7,000 kilometers per hour, the heliosphere acts like a protective bubble, deflecting interstellar particles. Scientists study this region to understand how the environment of space can influence cosmic rays, shape the heliosphere, and even subtly impact Earth's climate. We are not stationary in space. We are gliding slowly, silently, through a diffuse galactic fog. Some moons are restless, alive with activity. Geological energy is not limited to planets. Several moons in our solar system display dynamic internal processes and ever-changing surfaces. Jupiter's Io is covered in active volcanoes fueled by tidal heating. Saturn's Enceladus vents icy plumes of water vapor into space. Europa and Ganymede likely hide subsurface oceans stirred by internal warmth. Even Neptune's captured moon Triton shows icy eruptions driven by shifting pressures below its frozen crust. These satellites are far from static. They are worlds in motion, with geology, chemistry, and perhaps hidden habitats for life beneath their icy surfaces. Pluto's atmosphere is ephemeral. Though small and frigid, Pluto hosts a tenuous envelope of nitrogen with traces of methane and carbon monoxide. As it swings closer to the Sun in its elongated orbit, surface ices sublimate, forming a fleeting, layered haze around the dwarf planet. As Pluto retreats, its atmosphere freezes back onto the surface. This cycle repeats over its 248-year orbit. During NASA's New Horizons flyby in 2015, this delicate blue haze was captured, a brief, ghostly breath of warmth on a world that spends most of its time in deep cosmic winter. At the Sun's core, temperatures soar beyond imagination, exceeding 15 million degrees Celsius. Hydrogen nuclei are crushed under extreme pressure, fusing into helium and releasing tremendous energy. This nuclear fusion powers sunlight, heat, and the very conditions for life on Earth. The energy takes hundreds of thousands of years to traverse the Sun's dense plasma layers before escaping into space, reaching Earth in just over 8 minutes. Beneath its radiant calm lies a heart of unimaginable heat and power. Uranus, though distant, hosts its own subtle ring system, 13 faint rings, composed of tiny rock and ice particles, orbit the tilted planet. Its outer boundary, the heliopause, marks where the Sun's influence fades and interstellar space begins. As the Sun orbits the Milky Way, the heliosphere drifts along with it, acting as a cosmic shield against the changing environment of the galaxy. Mercury's unusual orbit once helped prove Einstein's theory of gravity. For centuries, astronomers noticed that the planet's closest approach to the Sun, its perihelion, shifted slightly over time, an effect Newton's laws couldn't explain. In 1915, Albert Einstein's general relativity showed that massive objects like the Sun warp spacetime, subtly altering planetary paths. Mercury's orbit matched these predictions precisely, providing one of the first experimental confirmations of Einstein's revolutionary theory. A tiny scorching world became a proving ground for the mathematics of the cosmos. The Moon shapes Earth's tides in a silent, invisible dance. Its gravitational pull creates bulges in the oceans on both the side facing the Moon and the opposite side. As Earth rotates, these bulges sweep across the planet, creating the familiar cycle of high and low tides. The Sun adds its influence as well, producing spring and neap tides depending on its alignment with the Moon. These tidal forces do more than move water. They subtly flex Earth's crust and even affect the planet's rotation. There may be hidden planets beyond Neptune. Astronomers have found distant objects in the Kuiper Belt following unusual, elongated paths. One leading explanation is the presence of a massive yet undetected planet, often called Planet 9. If it exists, it could be several times the mass of Earth and orbit far beyond Pluto, taking thousands of years for a single revolution. While telescopes continue to search, The discovery of such a planet would reshape our understanding of the solar system's outer architecture. Jupiter's moon Callisto may conceal a hidden ocean beneath its icy shell. Though its surface appears ancient and cratered, magnetic readings from the Galileo spacecraft suggest a conductive layer beneath the crust, likely a salty subsurface sea. If confirmed, Callisto would join Europa and Ganymede as an ocean world, holding potential ingredients for life, quietly preserved beneath layers of ice and billions of years of history. Venus is hotter than Mercury, despite being farther from the Sun. Its thick atmosphere, composed mostly of carbon dioxide, traps heat in a runaway greenhouse effect, raising surface temperatures above 460 degrees Celsius, hot enough to melt lead. Mercury, by contrast, has a thin exosphere that provides little insulation, allowing its dark side to cool rapidly. Venus's extreme heat isn't simply a matter of proximity. It is the relentless power of a dense, radiation-trapping atmosphere. Saturn's rings are not solid bands, but shimmering collections of ice. Made of countless individual particles, from tiny dust grains to house-sized chunks, they orbit in a remarkably thin, flat disk. Saturn's gravity and the subtle influence of nearby moons maintain the ring's structure, creating one of the most iconic and delicate features in the solar system. Saturn's rings owe their dazzling brightness to ice. This reflective material makes the rings one of the most luminous features in the solar system when seen from afar. Within the rings, narrow gaps, waves, and delicate ringlets form, sculpted by gravitational interactions with Saturn's moons. These dynamic structures are constantly shifting, a frozen ballet of ice in motion. Ceres is both an asteroid and a dwarf planet. Nestled in the asteroid belt between Mars and Jupiter, Ceres is the largest object in this region. Its size qualifies it as a dwarf planet, and its spherical shape distinguishes it from smaller, irregular asteroids. NASA's Dawn spacecraft revealed mysterious bright spots on Ceres, which were found to be salt deposits, likely left behind by evaporating briny water. Ceres offers a unique glimpse into the early ingredients of planetary formation. Mars shines red because of rust. Its surface is coated in fine dust rich in iron oxide, the same compound that gives rust its familiar color. Over billions of years, this material oxidized in the thin Martian atmosphere, producing the planet's iconic reddish hue. Dust storms scatter this pigment across the globe, coloring the sky and cloaking the planet in a warm, rusty glow. Amid the red, darker basaltic plains and bright polar caps add subtle variations, but the rusty tone dominates from a distance. Sunspots are cooler regions on the sun's surface. Although still blazing hot at thousands of degrees, these spots appear darker because intense magnetic activity slows the outward flow of heat. Some sunspots are larger than Earth and often appear in clusters. They follow an 11-year cycle, growing in number and intensity as the sun approaches solar maximum. These magnetic scars reveal the sun's restless, ever-changing inner dynamics. Uranus was discovered using a telescope. Unlike planets known since ancient times, Uranus was first observed in 1781 by William Herschel. Initially mistaken for a star or comet, its planetary motion was soon confirmed. Uranus became the first modern discovery of a planet, marking the transition from naked-eye astronomy to instrument-based exploration. Its extreme axial tilt, faint rings, and icy moons have since made it a quiet revolutionary in our understanding of the solar system. The solar system is approximately 4.6 billion years old. Scientists have determined this age by studying meteorites, radioactive isotopes, and the oldest rocks on Earth and the Moon. It began as a swirling cloud of gas and dust, a solar nebula that collapsed under gravity, forming the Sun at its center. The remaining material coalesced into planets, moons, asteroids, and comets. Over billions of years, collisions, migrations, and cooling shaped the planets we see today, survivors of a chaotic early era. Vesta has a layered internal structure. As the second largest object in the asteroid belt, Vesta is a protoplanet with a differentiated interior, a dense metallic core, and a mantle much like Earth. This suggests it once experienced enough internal heat to separate into layers. The giant impact that formed the massive Rhea Silvia crater may have exposed parts of these layers. Vesta is a frozen relic, a planetary building block that never fully became a planet. The Moon experiences quakes. Though seemingly still and silent, the Moon occasionally trembles. Lunar quakes can result from Earth's tidal forces, thermal expansion from heating and cooling, or meteorite impacts. Some originate deep within the Moon, lasting up to an hour, far longer than typical earthquakes. Apollo mission data first revealed these subtle tremors, showing that even a seemingly dormant moon has a quiet, pulsing interior. Triton is a captured moon. Neptune's largest satellite, Triton, orbits in the opposite direction of Neptune's rotation, a retrograde orbit. This suggests it was not formed alongside Neptune, but was captured from the Kuiper belt. The capture may have disrupted Neptune's original moons and tilted Triton's interior, generating tidal heating. Today, it has nitrogen geysers, a thin atmosphere, and a frozen cantaloupe-textured surface, making Triton both a relic of the outer solar system and a moon shaped by a violent past. Neptune has 14 known moons. The distant planet is orbited by a diverse collection of satellites, ranging from large and mysterious to small and irregular. Triton dominates the system in mass, while moons such as Proteus, Naiad, and Larissa follow eccentric orbits, creating a complex and varied celestial entourage. Some of Neptune's moons are likely captured objects from the Kuiper belt, while others may have formed from collisions or debris. Most are icy and dark, reflecting very little sunlight. Their orbits provide clues about Neptune's turbulent past and possible planetary migrations, forming a scattered family of companions around a distant, wandering giant. The Parker Solar Probe is flying into the Sun. Launched in 2018, NASA's Parker Solar Probe is the first spacecraft to enter the Sun's outer atmosphere, the corona. It travels at extraordinary speeds, faster than any human-made object, and endures temperatures exceeding 1,000,000 degrees Celsius. A carbon composite heat shield protects it as it dips closer with each orbit, collecting data on solar wind, magnetic fields, and energetic particles. Its mission is to solve long-standing solar mysteries, such as why the corona is hotter than the Sun's surface and how solar flares accelerate. In effect, the probe isn't just observing the Sun, it is flying through it. Some meteorites on Earth originated from Mars. Though millions of kilometers away, fragments of Martian rock have landed here, blasted from the planet's surface by powerful impacts. Scientists identify these meteorites by comparing their chemistry with data from Mars rovers and orbiters. Some contain trapped Martian air or minerals shaped by water. offering direct insight into Mars's geological and chemical history. These stones are natural samples from another world, delivered long before any spacecraft returned the favor. The Sun is mostly hydrogen and helium. Roughly 70% of its mass is hydrogen, with most of the remainder being helium. These light elements fuel the nuclear fusion at the Sun's core, where hydrogen fuses into helium, releasing vast amounts of energy. The remaining 1 to 2% consists of heavier elements like oxygen, carbon, and nitrogen, forged in earlier generations of stars. Despite its complexity, the Sun is fundamentally simple, a glowing sphere of primordial gases powered by gravity and nuclear fire. Earth's tilt gives us the seasons. Our planet's axis is inclined about 23.5 degrees relative to its orbit around the Sun. This tilt causes the seasonal cycle. When a hemisphere tilts toward the Sun, it receives more direct sunlight and longer days, summer. Tilted away, sunlight is weaker and days are shorter, winter. Without this tilt, seasonal variations would be minimal and Earth's climates far more uniform. Over time, gravitational influences from the Moon and other planets have slightly altered this tilt, quietly shaping the rhythm of life on Earth. Jupiter's magnetosphere is the largest structure in the solar system. Extending millions of kilometers into space, it is so vast that it would appear larger than the Sun if visible from afar. Powered by electric currents in Jupiter's metallic hydrogen interior, this field channels charged particles along magnetic lines, creating massive auroras, radiation belts, and fierce electrical storms. It even captures particles from Io's volcanic eruptions and influences the orbits of nearby moons. While hazardous for spacecraft, it provides scientists with a natural laboratory for studying extreme planetary magnetism. Planetary rings may be temporary, though they appear eternal. Rings around planets such as Saturn, Jupiter, Uranus, and Neptune are likely short-lived on cosmic timescales. Rings form from shattered moons, leftover debris, or icy particles pulled into orbit. But over millions of years, gravity, collisions, and magnetic drag can cause these materials to spiral onto their host planets. Observations suggest Saturn's rings may be less than 100 million years old and could disappear within another 100 million. What we see today may be a fleeting, shimmering moment in a planet's much longer history. The Moon's surface barely changes over time. Without wind, rain, or active geology, its surface remains largely unchanged for millions, even billions of years. Footprints left by astronauts could endure for thousands of generations, frozen in a timeless lunar landscape. Micrometeorites and cosmic radiation are the main forces slowly reshaping the Moon's surface, a process known as space weathering. Over this cosmic year, the solar system drifts through different interstellar regions, passing through clouds of gas and dust, perhaps influencing comet activity, and even over long timescales, Earth's climate. We are not fixed in space, but part of a vast, slow spiral, riding the galaxy like a cosmic carousel. And so, our quiet journey through the solar system comes to a gentle close. From the inner world scorched by sunlight to icy moons whispering in the dark, we have wandered together through orbits, storms, and shadows, one sleepy fact at a time. If your eyes are already heavy, that is perfectly fine. Let the last traces of starlight fade behind your thoughts, and let your breath carry you softly into rest. In extreme cases, they can trigger geomagnetic storms capable of damaging power grids. Earth's magnetic field offers some protection, but solar flares remind us that the sun is not a steady light bulb. It is a dynamic, volatile star, occasionally sending ripples of energy across the solar system. The solar cycle influences auroras. Periodic changes in the sun's activity affect the number and intensity of charged particles reaching Earth. When these particles collide with our atmosphere, they create the shimmering green, red, and violet curtains of auroras. At the peak of solar activity, auroras can be seen at lower latitudes than usual, turning the night sky into a dance of cosmic light. Auroras, the shimmering curtains of green, red, and violet light near Earth's poles, are born from charged solar particles interacting with our magnetic field and atmosphere. These displays follow the sun's 11-year activity cycle. There is still so much more to discover, but for now, you have traveled far. The universe can wait until morning. Thank you for spending this time with me. Under the quiet stars, the story continues. Sleep well and dream softly. Good night. Over millions of years, these tiny impacts erode the landscape, while craters from ancient collisions still dominate the terrain, preserving a record of the solar system's earliest days. The Moon is not only Earth's closest companion, but also one of its oldest and most faithful geological archives. Some icy moons may harbor hydrothermal vents. Beneath the frozen crusts of moons like Europa and Enceladus, subsurface oceans may meet hot, rocky cores, creating vents similar to those on Earth's ocean floors. On our planet, these vents support entire ecosystems independent of sunlight, powered by chemical energy from minerals and heated water. If similar systems exist on these moons, they could provide the conditions needed for life: water, heat, and a steady energy source. Plumes from Enceladus even contain compounds linked to biological processes, making these hidden oceans some of the most promising places to search for life beyond Earth. During solar maximum, heightened sunspot activity and solar flares send more particles toward Earth, creating brighter, more frequent auroras. During solar minimum, the lights are quieter. The sun's magnetic fluctuations ripple across space, and we see their subtle brushstrokes painted in our skies. Comet tails always point away from the sun. As a comet nears our star, its icy surface sublimates, releasing gas and dust to form a glowing tail. But rather than trailing behind like smoke from a train, the tail always points away from the sun. Solar wind and radiation pressure push the material outward, forming two distinct tails: a curved dust tail and a straight bluish ion tail. The result is a luminous signature, tracing the invisible force of sunlight across the darkness of space. Over millions of years, these tiny impacts erode the landscape, while craters from ancient collisions still dominate the terrain, preserving a record of the solar system's earliest days. The Moon is not only Earth's closest companion, but also one of its oldest and most faithful geological archives. Some icy moons may harbor hydrothermal vents. Beneath the frozen crusts of moons like Europa and Enceladus, subsurface oceans may meet hot, rocky cores, creating vents similar to those on Earth's ocean floors. On our planet, these vents support entire ecosystems independent of sunlight, powered by chemical energy from minerals and heated water. If similar systems exist on these moons, they could provide the conditions needed for life: water, heat, and a steady energy source. Plumes from Enceladus even contain compounds linked to biological processes, making these hidden oceans some of the most promising places to search for life beyond Earth. Because Uranus spins nearly on its side, the rings appear almost vertical when viewed from above the Sun's North Pole. Some are narrow, sharply defined, possibly shaped by small shepherd moons. Unlike Saturn's brilliant rings, Uranus's are dark and elusive. First discovered only in 1977, when they briefly blocked the light of a distant star. Uranus's rings are subtle, shadowy bands encircling a planet that spins almost on its side. Unlike the brilliant rings of Saturn, these dark, narrow structures are delicate traces of rock and ice, quietly tracing the planet's unusual tilt. The heliosphere is a vast magnetic bubble inflated by the sun. As the solar wind, a stream of charged particles, flows outward in all directions, it forms this protective envelope around the solar system, shielding planets, comets, and other distant objects from harsh galactic radiation. Some planetary moons were born from giant impacts. Earth's moon formed over 4 billion years ago when a Mars-sized body collided with the young Earth. The ejected material gradually coalesced into a single orbiting body. Similar impact origins are suspected for other moons, such as Pluto's Charon. These violent beginnings contrast with the captured moons of the outer planets, showing that no single process explains all satellites. Some were born of fire and collision, others through gentle gravitational snaring. Their diversity reflects the chaos and creativity of the solar system's formative years. Voyager 1 carries a golden record into interstellar space. Launched in 1977, Voyager 1 is now the farthest human-made object from Earth. Affixed to its side is a golden phonograph disc containing sounds and images chosen to represent life on Earth. A frozen world, yes, but far from static. Saturn is less dense than water. Place it in a cosmic bathtub and it would float, not because it is hollow, but because its average density is lower than that of water. Composed mostly of hydrogen and helium, Saturn is light despite its vast size. Its volume exceeds 700 times that of Earth, yet its mass is only about 95 times greater. This low density gives it a diffuse, gentle structure, with rapid rotation flattening the poles and bulging the equator. A giant of gas, softly shaped by gravity and motion. Solar flares can disrupt technology on Earth. These sudden, powerful eruptions of energy from the sun's surface often stem from sunspot activity. Flares release bursts of radiation across the electromagnetic spectrum, including X-rays and ultraviolet light. Greetings in dozens of languages, music from across the globe, and recordings of waves, birdsong, and laughter are all preserved for any intelligent beings who might one day discover it. It is a message in a bottle cast into the galaxy, a quiet greeting from our pale blue dot. Earth shares its orbit with co-orbital asteroids. While Earth follows its yearly path around the Sun, it is accompanied by small bodies known as co-orbitals. These asteroids don't orbit Earth like moons, but instead trace stable looping paths near Earth's orbit. Some, called Trojans, linger at stable Lagrange points ahead of or behind our planet. Others follow horseshoe-shaped paths, staying nearby without colliding, invisible to the naked eye. These quiet companions drift alongside us, fellow travelers on our journey around the sun. Sunlight takes over 8 minutes to reach Earth. The light warming your skin began its journey in the sun's core, where nuclear fusion generates photons. These photons take hundreds of thousands of years to reach the surface, scattering through dense plasma along the way. Once they escape, they travel the final 150 million kilometers to Earth in just over 8 minutes. Watching the sun, whether at sunrise or midday, is therefore a glimpse into the very recent past. Europa's cracked ice may move like tectonic plates. Jupiter's moon is covered in a shell of ice, intersected by dark lines, ridges, and chaotic terrain. These features suggest the ice may shift, break, slide, and even subduct, similar to Earth's tectonic activity. This motion could help circulate nutrients between the surface and the ocean beneath, enhancing Europa's habitability. The driving force is tidal flexing from Jupiter's gravity, keeping Europa's interior active. A frozen world, yes, but far from static. Neptune was once confused with Uranus. Before its official discovery in 1846, Neptune's slow motion and dim appearance caused early astronomers to mistake it for a fixed star, or even for another sighting of Uranus. Galileo may have glimpsed it in 1612, marking it as a star. It wasn't until mathematicians noticed irregularities in Uranus's orbit that Neptune's existence was predicted and confirmed. In a sky crowded with wandering points of light, Neptune remained hidden in plain sight for centuries. The edge of the solar system isn't defined by gravity. While the sun's gravitational pull stretches far beyond Pluto, holding distant comets and icy bodies in the Oort cloud, the practical edge often refers to the heliosphere, the bubble of solar wind that shields the solar system from interstellar space. Beyond this boundary, the influence of the sun's energetic winds fades, giving way to the wider galaxy. Sunlight takes over 8 minutes to reach Earth. The light warming your skin began its journey in the sun's core, where nuclear fusion generates photons. These photons take hundreds of thousands of years to reach the surface, scattering through dense plasma along the way. Once they escape, they travel the final 150 million kilometers to Earth in just over 8 minutes. Watching the sun, whether at sunrise or midday, is therefore a glimpse into the very recent past. Europa's cracked ice may move like tectonic plates. Jupiter's moon is covered in a shell of ice, intersected by dark lines, ridges, and chaotic terrain. These features suggest the ice may shift, break, slide, and even subduct, similar to Earth's tectonic activity. This motion could help circulate nutrients between the surface and the ocean beneath, enhancing Europa's habitability. The driving force is tidal flexing from Jupiter's gravity, keeping Europa's interior active. This edge, called the heliopause, marks the point where the sun's magnetic field and the flow of solar particles fade into interstellar space. Gravity continues far beyond, but this energetic boundary is where the space between stars truly begins, a subtle shifting frontier defined more by pressure than presence. Planetary atmospheres slowly leak into space. Even thick atmospheres, like Earth's, aren't permanent. Light gases such as hydrogen and helium can escape a planet's gravity over time. This process, known as atmospheric escape, is more pronounced on smaller worlds with weaker gravity, like Mars or Mercury. Venus, lacking a strong magnetic shield, has lost parts of its upper atmosphere to the solar wind. On Earth, thousands of tons of hydrogen drift away each year, a quiet, ongoing exchange with the vacuum beyond. Some moons may have formed from ring systems. Just as rings can decay or vanish, they can also give birth to moons. Saturn is less dense than water. Place it in a cosmic bathtub and it would float. Not because it is hollow, but because its average density is lower than that of water. Composed mostly of hydrogen and helium, Saturn is light despite its vast size. Its volume exceeds 700 times that of Earth, yet its mass is only about 95 times greater. This low density gives it a diffuse, gentle structure, with rapid rotation flattening the poles and bulging the equator. A giant of gas, softly shaped by gravity and motion. Solar flares can disrupt technology on Earth. These sudden, powerful eruptions of energy from the sun's surface often stem from sunspot activity. Flares release bursts of radiation across the electromagnetic spectrum, including X-rays and ultraviolet light. When directed at Earth, they can disturb the upper atmosphere, interfering with GPS, radio communications, and satellites. Around Saturn, some small outer moons may have coalesced from ring material beyond the planet's Roche limit, the distance where gravity allows clumps to form rather than be torn apart. Moons like Pan and Daphnis, orbiting within Saturn's rings, may still be accreting material today, quietly sculpting gaps and waves in the icy bands around them. Voyager 1 continues to send data from interstellar space. More than 45 years after launch, it still transmits faint signals back to Earth, measuring cosmic rays, magnetic fields, and plasma density between stars. Its power is limited, and some systems are gradually shutting down to conserve energy. But this tiny spacecraft, powered by nuclear energy, remains functional. Each signal takes over 20 hours to reach us, a faint whisper from the edge of human exploration. The solar system completes a galactic orbit every 225 million years. While the planets circle the sun itself revolves around the Milky Way's center. When directed at Earth, they can disturb the upper atmosphere, interfering with GPS, radio communications, and satellites. In extreme cases, they can trigger geomagnetic storms capable of damaging power grids. Earth's magnetic field offers some protection, but solar flares remind us that the sun is not a steady light bulb. It is a dynamic, volatile star, occasionally sending ripples of energy across the solar system. The solar cycle influences auroras. Periodic changes in the sun's activity affect the number and intensity of charged particles reaching Earth. When these particles collide with our atmosphere, they create the shimmering green, red, and violet curtains of auroras. At the peak of solar activity, auroras can be seen at lower latitudes than usual, turning the night sky into a dance of cosmic light. Micrometeorites and cosmic radiation are the main forces slowly reshaping the moon's surface, a process known as space weathering.